So in this video, we will go over the Leetcode question number 104, maximum depth of binary tree. Given the root of a binary tree, we must return its maximum depth, where the maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. For example, look at this example number 1. So the longest path in this tree is 3, 2, 20 and 15. The other path is 3, 20 and 7. So in the right node, the longest path is this, because here the nodes are larger as compared to the left node. So the maximum depth is 3. Now we know the way that we are going to solve this question is by using the recursion. Here a quick overview of recursion if you are unfamiliar. So first understand the recursion. Let's say you are given a list of items and you were asked to find the length of the list. Well, you will see that there are at least one item at the beginning, so you could recursively define the length of the list of this list and say it is the one plus the length of the rest of the list. And this begs the question, well, what's the length of the rest of the list? And we can find this by using the same recursive definition. Again, we can see what is the least one item at the beginning, and it keeps going the length. It keeps going the length of this list is 1 plus the length of the rest. First 1 plus at this point 1 plus again, and also at this point 1 plus, and at this point also 1 plus. So the length of this list is 1 plus the length of the rest, and the length of that list is again 1 plus of the rest, but at this point now hit something different. We see that the rest of the list is now empty. This means that we have hit in is the best case. So we know that there are 0 items, so add here 0. So now we done with the recursion, and we can finally figure out the length of the entire list, which is 0 plus 1 plus 1 plus 1 and plus 1, which is equal to 4. So now, of course, practically speaking, it would be much easier to just loop through the list and count it iteratively. But as you will see in a second, when working with more complex data structures such as trees and graphs, solving things, recursive can result is much cleaner and more concise code. So let's see how the code works. So let's see the same tree as before. We will also be using definition of the tree node. Here each node has three attributes, which is the value using inside each node. And at this point, left, which is the pointer to the left child node, and the right pointer is to point the right child node. If either pointer points to none, as this node it points to none, there is no other element in its left and right side. This means there is nothing there, and we don't count that as a node. We start by pressing in the root node of the tree into the function, which is the node in which is the its parent leaf node. Our base case will be if the node is equal to none, because that means we are reached. That means we are reached the end of the path and there is nothing left to traverse. So in that case, since there are no more nodes to count, we can just return 0. In this case, in the left side there is no more nodes, so it's empty, so we don't need to traverse, and we simply reach the parent node and return 0. Otherwise in the right. Now the root node does not equal none. So start the recursive cases. First we'll find the maximum depth of the left branch of this node by recursively calling the maximum depth. The function and pressing in the left node, which is pointed to the left node. So a small node here, if you are doing this inside the Leetcode environment. Since Leetcode forces your solution to be part of a class, which function call will have to be set dot maximum depth. So, but for now, I will be sticking to more general solution. So at this point, we are going to call maximum depth. And press in root dot left, the left dot node I am going to pin now. I'm going to pin tree node, parent node here, and this line shows that this is where we left off in the function, and where the parent node is the root. So let's enter in this new function, and now this node is the root. So enter another recursive call to find the maximum depth of the left branch of this node. So again we call the maximum depth and press and pass in the left node. This time I will leave this node and do to match the node, but now notice the left node is actually none. There is no other node after this node, so we enter the newly called function, and the root is now equal to none. We finally hit the base case, and since we know that there are not any node in this level, we can return 0 and go back up the tree. So we are going to exit this function and return to function with the node. Is this node? So now that we will back, I will remove the node. So we will return to 0. So the variable left node is assigned a value of 0, which will indicate directly to the tree here. Now that we are traversing the left branching, we can move on and find the maximum depth of the right branch, and we will exit the same way by recursively calling the maximum depth, but this time passes the right node. So in this case, the right node, the path is longest, which is the 3, 20 and 15, and the 3, 20 and 17. So we simply return 3 because this is the longest path of our tree.